it's Mary and welcome back to Study Journey. So I'm back with another AMC problem of the week, AMC 10, and it is on angle bisectors, like how to use it and use it to solve problems. If you don't know what AMC is, my video on what is AMC will be linked down below. You can go check that out, and without further ado, let's get on with the video. This is AMC 10A, problem 16 of the year 2010. Non-degenerate triangle ABC has integer side lengths. BD is an angle bisector. AD equals 3, DC equals 8. So what is the smallest possible value of the perimeter? Keywords here are non-degenerate, and then integer side lengths, and this is an angle bisector. So what is the possible value? So the answer choices are 30, 33, 35, 36, and 37. So let's mark all the information that we know. We know BD is an angle bisector. So that means CBD has to equal DBA. So these two angles are equal. And then it also says that AD is 3 and DC is 8. So AD, this is 3 and this is 8. And it is asking what the smallest possible value of the perimeter, which is these three sides added together. Now that we've marked all of this, let's look at the keywords. Non-degenerate. A non-degenerate triangle, this just means that it is a triangle that has a positive area. So this triangle ABC has a positive area. Now, since it says that it is an angle bisector, we can look at the angle bisector theorem. Maybe that will help us figure it out. So what is the angle bisector theorem? The angle bisector theorem, it just says that in any triangle ABC, the angle bisector AD, where the D is on the side BC, then there is always C over M equals B over N, and C over B equals M over N, which you got from the first equation. When this is the angle bisector, then these two angles are equal. So it is saying this side divided by this side is equal to this side divided by this side, which is also saying that these two will be proportional. Now let's look at the problem over here. Over here it says that BD is the angle bisector, so we can get that from here the C over M equals B over N. In this triangle it will be CB over A is equal to BA over 3. So if we put the variables on one side and the numbers on the other side, we get AB over BC is equal to 3 over 8. Since it is asking for the lowest possible integer value of the perimeter of the triangle, so it is asking what is the smallest possible value that AB plus BC plus 3 plus 8 can equal. So that will equal AB plus BC plus 11. So you're just trying to find what is the smallest possible values for AB and BC. And we already know that the proportion of AB divided by BC is 3 over 8. Well, let's just try with the lowest possible integer value for AB and BC, which would be 3 and 8, because that is the lowest number where it is an integer. So if AB equals 3 and BC equals 8, then AB plus BC equals 11. And then you can also see here that AD plus DC is also 11. And since AD plus DC is equal to AC, so it is saying AB plus BC equals AC, which is saying these two sides of a triangle is equal to the third side. And we know that is not true from the triangle inequality, which is saying that two sides of a triangle must be greater than the third side of the triangle. You can't use this one. So let's try the second smallest possible value. So we can multiply 3 over 8 times 2, and that would be 6 over 16. So if AB were to be 6, and then BC equals 16, then we would get AB plus BC. So we know that AB plus BC equals 22 and AC equals 11. So the two sides of this triangle is greater than the third side. So it satisfies the triangle inequality. And then let's find the perimeter, because this would be the smallest value where the perimeter is the lowest possible integer value. So since AB plus BC plus AC is equal to 33, then that would be our smallest possible value for the perimeter. Now let's look at the answers. Here we can see that the answer will be B, which is 33.